Afternoon, everyone. I'm going to be talking tonight about the combination of Docker, .NET Core, and Linux, or as I like to call it, the hipster approach to .NET development. Now, what that means is that we are going to be combining three different technologies. There is Docker, the containerization tool that I'm sure many of you are familiar with now, .NET Core, the future of the .NET platform, and Linux, the greatest distribution on the planet, no questions asked, don't even try. And the short version is that you put all three of these things together and you get amazing things, and you get an amazing developer experience with some awesome power. Now, this is what I'm going to be talking about today. There's actually quite a bit to get through, and I hope you guys are cool with some live coding, because there is definitely demos involved. There's also a fair bit involved, so it might be rushing through a little rapidly, but we'll see how we go. Now, basically, this is going to come down to pretending to know about all of these things. If anyone questions, I know everything there is to know about all of them. Now, a little bit about myself. I'm not actually a developer by trade. I'm an information security architect. I'm from Australia, so if I look tired, there's a good reason for that. You can find me on Twitter and GitHub and a bunch of other places as AGC93. My primary environment is working in Linux, and my primary language is C#, which up until now has been rather an unfortunate combination. But now, with the wonders of modern technology, we're in a much better thing. Now, before I get too far, I want to cover off a note on some moving targets. Now, this year at the conference, Docker announced a whole bunch of changes with how Docker is going to become merely an assembled version of the Moby project, and there was some governance changes and a whole bunch of projects going on, and I'm just going to pretend none of those happened, because they're actually quite complicated. So, for all intents and purposes, anything you see me doing with Docker is effectively Docker CE, what they call their community edition. Likewise, the .NET Core parts, I'll be switching a couple of times between the 1.1 release and the new preview of 2.0, because particularly for Linux users, there's a lot of improvements there, including much better support. Also, about a week ago, Microsoft actually published their own documentation, sample code, the works, on exactly what I'm talking about here. So I'll include links in the slides at some point, and you guys can have a look at that. Now, to get into the crux of it. Docker, for those who don't know, is a containerization tool. It provides isolation at a process and an environment level for individual processes. You're effectively all sharing the same kernel and running in separate user spaces. Now, it's supported on Linux really well, because it's all built into the Linux kernel. It's supported mostly on Windows. If you're on Windows 10 Pro, or Windows Server 2016, it's all native to Windows through Hyper-V. It's brilliant. If you're on non-Pro versions or an older version, you have to run Docker Toolbox, which is actually just a virtual machine and a lot of clever pass-through. Likewise, macOS is all virtual machines underneath. They are currently undergoing a minor identity crisis, as I mentioned. There's a lot of confusion around what's Moby and what's Docker and what the company's doing, but we'll breeze over that. Equally, .NET Core, we all know at this point, is the next generation of .NET. It's supported beautifully on Windows. It's supported mostly on macOS. There's some minor issues with SSL, and it's supported sort of on Linux. .NET Core 1.0 realistically only works properly on Ubuntu and CentOS. 2.0 fixes a lot of those problems, and you can get it working on a lot of other places, but particularly the SDK poses some challenges. So, the bare essentials. Let's jump into a quick demo, shall we? So let's have a look at a basic application. Ooh. Hang on. There we go. That's what you get from .NET New. Okay, all we have here is a very simple program. It says hello, and a CS proj. Nice and simple. Now, so far, this is all just bog standard .NET stuff. Anyone can work with this. So much so that, that's a bit of a problem. Yep. Yes. I imagine so. Perfectly normal, average, stock standard. And let's go with app with. Now, the fun one we can do here is that I can see that is a 2.0 release. So I run that command. And if it works, we restore .NET. So now we're interactively inside a Docker container that you can see by that host name there. This is not my host machine. I can build it. And in a second, and I can run it. And we get the all-important hello world, which is still a bit small. Let's make that a little bigger. That's what we're all here to see, is the words hello world. That's app development covered. We're all sorted. Don't need to do anything more. Now, this is obviously running all inside a Docker container, and this is using Microsoft's own images. Now, images define essentially the spec for the container. And here we are, in fact, running underneath Debian 8.8, which is Microsoft's choice for the 2.0 SDK. Now, the complication comes that it may not always be quite so simple. That I'm looking at this. Oh, hang on. Now we've got Project.json. Now, again, I don't have .NET on here, and even if I did, I wouldn't have the right version, because obviously Microsoft moved off that onto CSproj, and so we're stuck. There's nothing we can do, and we'll have to upgrade the entire thing if we want to do anything. Or we create app, and we use tags. Now, tags allow you to specify a particular version of a container. Now, you'll notice again, now we're no longer in Fedora, which is what the host machine is in. We're in a slightly older version of Debian. But I can now do a .NET Restore on a Project.json. Equally, I can do .NET Build and .NET Run. And we get the all-important hello world. Again, same machine, no .NET Core SDK installed at all. This is all happening inside the containers. And just to prove that it is just normal SDK, we have another version of the new CSproj here, this time using the CLI tools for .NET Watch and the .NET Secret Manager. Now, if we try that same command again, but this time using, we note that up here, this is .NET Core 1.1 again. If I can find my mouse has gone walkabout. Oh well, it's 1.1. Means we can change to the 1.1.2 SDK. And again, so this restore will take a little bit longer because it's doing the command line tools as well. And this internet's not ideal. And we get the build, and we should get the all-important hello world. The important thing is we've also now got at our command the .NET User Secrets tool that was included in the CSproj. Equally, I can run .NET Watch, and that's there. Now again, to prove the point, I don't have .NET installed on this VM at all. It's simply not there. All of those restore, build, run operations are all happening inside a container running locally on my machine. Now, getting started with Docker is pretty easy. It's basically just an install away. So you can use this to very quickly and easily pick any version of .NET Core you need on any distribution of Linux, whether it's supported by Microsoft or not. Anything that Docker will run on, these will run on. Now, what you can also do, if you have a sense of the nostalgia like I do, is set yourself up some aliases. And so now I have dnvm at my command all over again, so I can quickly and easily jump between them. Now all that is actually just bash, which is nice and easy for anyone to get the hang of. And that's just spinning up containers underneath using the correct tag of the container, depending on what version of the SDK you want. So, when you're building your own apps, like our excellent hello world there, it's all well and good to be building things and interacting with a Docker container to avoid problems with your host environment. What's just as cool is being able to build for Docker rather than build with it. Now, it's very easy to do that. You simply add a Docker file to your image. So you add a Docker file to build an image. You can then run your image to create your app in a container. So the one you see down here is a very basic Docker file for a .NET app. We're building against 1.1.2, and this set of instructions here is exactly what it sounds like. It's telling Docker, these are the things I need you to do to build my app in a container. We're telling it that I want to start with the .NET SDK. I'm going to copy the current directory into /app, effectively cd into app, run .NET Restore, run .NET Build, and expose port 5000. This last instruction here doesn't actually get run when you build the container. What that actually does is sits there, and when you go to execute that container, that's what gets run. Now, we should have one here that I can use to demonstrate. So, again, I've lost the mouse. There we go. Again, you have a bog standard program CS. There you go, Scott, again. Now, I can do a .NET Restore here, and this should work. Oh, sorry, that's hidden. My mouse has stopped working. Brilliant. There we go. There we go. Now you can see that a bit better. And when we run that app, we are running a web API. Let's make this huge so that you can see that we are actually running that. Let's curl. And we get the all-important value 1, value 2. That's every web API underneath is actually just returning value 1, value 2. Now, this is running locally on my machine. Now, that's not all that helpful. So what we can do is add a Docker file. And so I've added a Docker file that, again, it's a little difficult to see, but that is doing the exact same thing as you were just looking at. This is running .NET Restore, .NET Build, and then running it there. Now, what we do to build that is we give it a name that I can remember, and we build it. And it will run each of those statements from that Docker file in turn, one at a time. We've just copied in the output. Now it's going to change to that folder, start running restore, run build. And it won't actually start the API yet. All this has done is create an image that we can use to then run our app. Now, if we give that a second to run. Now, while that's running, I will say that the Docker official documentation on all of this is incredibly helpful. If you go through the tutorial, they'll explain all of the concepts that I'm glossing over a bit here, with the differences between what's an image, what's a container, what the daemon underneath is doing, all those sorts of things are all covered quite well in the documentation. A lot of it is not necessarily .NET specific, but as I pointed out, Microsoft's got a lot of information there now to provide you with easy samples for you to get started with and those sorts of things. Now that's almost ready. And again, you can see this is running against .NET Core 2 as well. So that expose 5000 is important. What that's saying is it's telling Docker that something inside the container is going to attach to 5000. You don't know what it is, and it's not actually using it yet, but there's something in there. Now, if you just run that image that we just created, it will use the image we built, and it will run it as, there we go. And the application started. Now, unfortunately, that's not actually going to do anything. That won't be listening on the right host. It won't be doing anything. So we can test that by trying to get it, and there's nothing. Because since Docker isolates everything, we need to instruct Docker and say, but I actually want to access port 5000, and it will run the same image, but this time, what we've done there is tell it that port 5000 on our host, the first number, should be bound directly into port 5000 on the container. This way we can expose services running inside our container, and theoretically, oh, that's unfortunate. I know what that is. It's using, because we've used localhost, and we're not on localhost anymore. Take word for it that that is how you expose services. We'll see it again later on, so it's not the end of the world here. So this spec here is a Docker file is telling us what to build, not necessarily what to run, because those were those run commands I was adding in there. So we just saw Dockerifying a basic .NET app. That's pretty simple. Now we get to one of the more powerful ones, which is something I actually briefly touched on before, which is building things with Docker in your pipeline. So when you're building a .NET app, you might be used to just running Visual Studio, hit build, hit F5, and everything runs. But there's a lot of awesome capabilities you can bring in by adding Docker to your pipeline. There's important things like we saw before with being able to dial up your own SDK. You can set up DNVM if you're feeling nostalgic, and easily spin up any number of different things. You can also, using .NET Core's new publish abilities, you can run specific versions of an app for, let's have a look. Now you could use, actually we don't even need to do this with the new version. What we can do is say that I specifically want to restore for the CentOS 7 runtime. This is just like a normal restore, and it's going to restore the packages from my project. What it's also done is restoring the native libraries that .NET Core needs to run on, in this case, CentOS 7. Now that's why it's taken a little bit longer, and you can see up here these runtime Unix libraries. So these have installed the native components of .NET. The reason we do that is that we can now build our app, and using the built output, again, this is just the basic web API .NET new sample, and we can run this publish command. This publish command, by including a runtime, this is again not Docker yet, this is just normal .NET Core, has created a specifically CentOS 7 version of it. Now if we jump into bin debug grab CentOS publish, where it says it created it, I can now have a look at what's here, and we've got a whole bunch of libraries. Now the important one we want to look at is this runtime library that'll be down here. That's a lot of native components. There we go. We see a version of runtime there that doesn't actually have an extension. The reason that's not there is that runtime is a copy of the .NET Core runtime itself. It's an unfortunate name, but it's a copy of .NET Core that's built natively for CentOS 7 and contains all the libraries needed for .NET Core and for your application in one executable. What it's actually doing is it's effectively a renamed version of .NET. And it's just going to call out to runtime DLL, same as the .NET command does. But now you don't need to even have .NET installed on your target machine. Now, there is still some native compatibility requirements. So for CentOS, for example, you need libicu and libunwind. Now, I'm hoping this one gets a little flaky, but let's see how it goes. I should be able to run CentOS 7 bash. Oh, that could take a second. That'll take a minute. So I can spin up CentOS 7, and if I install libicu and libunwind that .NET Core needs, and move that output into there, without .NET being installed in your container at all, you can run the app. No .NET installed, you don't need custom base images. All you need is the ability to build for native runtimes. Now, while that, oh, hang on, that was faster. So, if we do install libicu, see how good the internet is here. Oh, actually, sorry, I haven't bound those in. Inside CentOS itself, we don't need a copy of .NET. All we actually need is a copy of our app, which we know is in demo. Yep. Alistair Chapman, runtime, bin, debug, .NET Core, CentOS, publish. Now that just works, rolls off the tongue. Now, again, we do what we were doing before, and we install some dependencies. And we'll let those run. Because it's packaged internally, your Docker containers end up much smaller. For example, the image we were running before, the Microsoft/.NET one, is a complete copy of Debian 8.8 in the case of .NET Core 2, with all of the dependencies, the full SDK, the runtime, everything. Using the native publishing abilities of .NET Core, you can use any container, any base image that there is a native support for. Now, the list of that is very, very long and includes basically everything, including macOS, interestingly. But we should now be able to run, if we make it executable, runtime, and if we now run runtime, we have a .NET app running. In Docker, no copy of .NET installed. There's no SDK on this machine. It hasn't changed at all. But using the combination of the native publishing abilities in .NET Core, which is still there in Project JSON, but was not well surfaced, the fact that it produces that runtime binary is the same one that we're executing here, and we can run in that container a .NET application. No .NET required. Now, there's also a whole suite of extra things you can do with containers that you can't usually do. The one I want to very quickly demonstrate, and I don't have a lot of time, so it will be sort of you'll just see it happening, is that I can go here, and this is an application, just a command line application that I did a little while ago. Now, I'm going to run, this is actually a cake build you'll see running here, which is what I was talking about earlier in the day. This is going to run once I fix the permissions issues. And get my password right. There you go. This is going to run a cake build. And in it, it's going to do all that native publishing things that I was showing before, but now with less mistyping involved because I can pre-prepare that. So this is going to publish runtimes for, we can see it publishing Windows 10 now, and it will publish it for Windows 10, RHEL 7, CentOS 7, Fedora, actually Debian 8, and Ubuntu 16.04, I believe. And if we have a look once it finishes, you'll be able to see the native binaries. There's just that, well, obviously this one's called Git Profile Manager, but it'll create that native binary for each. So on macOS, it creates the Mark II image. On Linux, it will create an ELF binary, and on Windows, it creates a .exe. Again, they've all self-contained. They contain the entirety of .NET Core needed to run inside the binary itself. The reason I cover this is that after it finishes publishing these, it's also going to run a set of Docker commands. And the reason I've got Cake doing it is because the Docker commands themselves are outrageously lengthy. Like, that long. What, what that's doing underneath is calling out to a Docker image with a package by the name of FPM installed. Now, FPM is a package manager built in Ruby that can build native packages for a whole bunch of different distributions, for Linux particularly. And in those containers, we don't have a copy of our app. Now, if we just run, so there we go. It doesn't know what the heck we're doing. If, however, we go have a look at our cake build, it's running as we speak. That is perfect timing. And it is building a Debian package in a container. Now, all you have to do with that is bind a folder inside your container to a folder on your host machine, and anything you build inside the container gets dropped into the same folder on your host machine. Important thing there is you're guaranteed a clean environment every single time. Every time you run Docker run, you get a whole new copy of whatever environment you're using. So we can just as easily run, for example, for the Windows users, there is Chocolatey running inside a container running against Mono 3.12. Now, I don't even have Mono installed on my host machine, but we've got Mono 3.12.1 there, and these are all the Chocolatey tools you need. Now, on the added advantage is not only do you not have to have Chocolatey installed, and you don't have to sit there matching Mono versions around, which anyone who's used Mono for a while can often be a pain, but you can now run it on CI systems. Any CI system with Docker on the other end, which is lots of them these days, can now instantly run a container with, in our case, so if we have a look at E3, sorry, just, we've now got local copies of all the libraries there. They all get packaged in using this new spec file here into a Chocolatey package that gets automatically built. To show what I mean, let's jump into the packages folder and have a look at what we've got. We have an RPM for CentOS 7, we have Debian 8 dib, we have RPMs for RHEL, and Debian packages for Ubuntu 14.04 and 16.04, and a Chocolatey package for Windows 10. All of that, like I said, don't have as much time to go through this one, but all of that was happening inside Docker containers. The Windows packages are being built against Mono and Chocolatey. The other packages are being built using FPM. On my host machine, I don't have Chocolatey. It's not there. I also don't have FPM, because FPM needs Ruby, and I don't hate my machine. All those commands are running inside containers and being bound together. Now, I will try and briefly show you what those actually look like when they're running, but it's gone off the top of my scroll back already. But you do essentially have to run a command along those lines where you bind in your published artifacts into the container, run your tool, and bind the packages that come out the other end back onto your host as well. So Docker containers give you a lot of advantages. They give you isolation, they give you a guaranteed clean environment, and ideally, if your build pipeline's up to the job, you should get the same build every single time. Because if you're using the same scripts with the same artifacts in the same environment, you should get the same builds. It's worth noting containers won't give you a few things. They won't give you real-world usage, so your users are still going to report bugs that your Docker containers won't have, because Docker containers, generally speaking, are bare. There's no SDKs installed, there's only the runtimes you need, there's as little installed as is humanly possible. Also, don't fall into the trap of thinking it's going to be drastically more secure. Docker does provide isolation, which when you're running slightly sketchy code is good. It's not going to prevent hostile code from breaking out of a container. And you don't necessarily get compatibility guarantees. There are going to be things in a Docker environment that aren't there on your users' machines, and vice versa. Equally, there's things that will seem to work just fine, but won't when you go to a real machine. The fun one is the .NET Core 2.0, for example, works in Ubuntu 14.04, but not in 16.04 unless you sit there mucking around with repositories for a while. Building for Docker. Now, this will be a fairly quick one, but it's essentially a case of how do you build apps knowing that you want to deploy using Docker in production. Most people are going to be deploying onto, for example, highly scalable environments, or just want to be able to deploy multiple copies of the same app side by side, things like that. And the proper way to refer to these is that you're building cloud-native apps. And that's a very fancy name for what essentially, when you get down to it, is just doing what all the other cool kids are doing. Now, again, that means that you might be taking it very seriously and looking at some cloud-native infrastructure for your new project. That would be good. You may also just be practicing hype-driven development and following what everyone online tells you to do. The two are not bad. I would strongly recommend trying this out for a while, absolutely mucking up your host machine like you wouldn't believe, and then acting like you know everything when you get around to building the real stuff. Now, I do have this is going to be a very quick demonstration, and this is what I was referring to earlier with the how to be a Magpie dev in a nutshell. So let's make this enormous and jump into a demo. Demo 1, and we've got an app. It's a very basic API, web API, that's all it is. Now, if I run into that, source type, and I do our standard commands, but preferably type it correctly. That'll take a second. All that's going to do is build a standard ASP.NET Core web API. This is all running locally. This is on an Ubuntu machine in this case. Now, the reason we want to do that is because this is the greatest app on the planet. What this app does is gives you your new startup idea. Because everyone knows that, well, I mean, you can say, I'm a millennial. And there's only 3 things millennials like: microservices, startups, and complaining about microservices and startups all the time. Now, what this API has given us, when it actually runs, helps if you have the right port, is the next startup idea. I present to you Soylent for presentation tools. Now I can also help that and have a better API. So it's a social network of pilots, which is actually not that awful, but compared to things like a Node.js server for whiskey lovers, it's probably getting a little bit more generic. Now, so this is good. This is an API that gives you startup ideas. That's pretty good. Yeah, you might be willing to show your face at the local JavaScript meetup, but that's not going to get you everywhere. What you really need is to run it in a Docker container. So now we have a Docker file, same as the one we saw before. And we can run up, and we have a quick script here to run this. So that's going to do the same thing we were doing before with building it into a container. This is again using .NET Core 1.1, and it's the same API we saw before. We'll be able to hit the ideas endpoint and get the next greatest moneymaker. But this time in a container, which means it makes even more money than it would have before. Now, let's try this. Ah, brilliant. That's not working at all. Oh, I know what that is. Now, that's because I can't code to save my life, and this is an old copy of it that's not actually binding to, it's binding specifically to localhost, which means inside the container, it's going to work beautifully. That's not of all that help to you. Because we're running very short on time, we're going to skip right over that, stop that container, and go straight for the awesome one. Now we are in business, because now not only can you show your face at the local JavaScript meetup, you can run it because you've got microservices. We've got multiple microservices. We have an API running the hype service, which is good. We've got an API running the hype estimate service. And we have this Docker Compose file. Now, a Docker Compose file puts together multiple containers. It means that you can run this container, this Docker image that gets built out of the hype folder as the API container, and run this estimates one as a separate container. Now that'll take a minute to build, and in the meantime, every time, we'll let that run. Now what that's going to do is a couple of things. It's going to jump into that hype folder, build an image, that hype estimates folder, and build an image. The reason I use Compose is because Compose is designed to orchestrate multiple services into one larger application. It's particularly common with APIs because it works quite well. Now, what we can get now is I can run against 5,000, and it's not actually there. Because if we have a look at the Docker Compose file, it said up here that it's on 5001, which means you can run any, no matter what port the application inside your container is running to, you can bind it to a totally different one. So now we're going to get a brick and mortar solution for camp counselors that'll take 6 to 8 weeks to complete. Now it's total coincidence that every single idea takes 6 to 8 weeks to complete. It's nothing to do with it. Amazing how that happens. Now that was the extremely crash course, because I'm extremely out of time, on composing multiple services in smaller Docker containers. Architecting for Docker is a bit different. It requires loose coupling, isolation, and as stateless as possible. Hence, it's well suited to microservices. Now, so these are the great principles for service-oriented architecture. Sorry, I mean microservices, and they're definitely different things if anyone asks. What these actually are is preparing yourself for this. When you need a scapegoat, just go with the architecture. No one can question you. What we just did there was essentially this. We're trying to be as cutting edge as possible. In reality, you're not going to build like this all the time. It's going to be much simpler scenarios, and most of the people in this room probably aren't building microservices that are going to be scaled out to web scale or whatever we're using these days. So it's important to remember that you don't necessarily need to throw Docker at everything. It may help, and there's a lot of cases where it will, but just because you're running your app in a container doesn't mean your app is going to be any better than it was before. So where do you go next? Try it out for yourself. It is very simple to get started. On Windows users, you can put a VM on your machine, or you can finally see the light, replace Windows, put Linux on there, and you'll be happily ever after. Windows users who are committed to the cause, you might want to check out Windows containers. Windows containers are built on the Windows kernel rather than the Linux one, so you can try them natively. Again, that's for pro only. There is a whole area of Docker I'm not touching, which is schedulers. So that's things like Kubernetes, Mesos, Docker Swarm, and a whole bunch of others, mostly startups, developing a lot of things. Kubernetes, for example, is very common, and I would strongly recommend if you are working in containers already, looking into it. It does also mean that you can host on your platform of choice. Azure has container service, Google has Container Engine, bizarrely acronymed to GKE, Red Hat has OpenShift, and AWS has ECS, I believe it's called. There's a whole bunch of things you can do with that. Now, I'm getting very dirty looks from the corner here, so I'm AGC93 essentially everywhere. You can find me at the conference this afternoon or tomorrow if you want to talk more about it. Blog's there, GitHub's there, and most of this code will be up there as soon as I get it cleaned up and put together. Thank you.